Hi, welcome back. Okay, let's take a look at this first example. Let's move this guy out of sight for a minute. We'll bring him back when I'm ready to work him. So let's talk about just finding the exact value of the cosine of 75 degrees. And you may be wondering, there's no angle sum there, so how are we going to use the angle sum identities? Well, what we're going to do is we're going to think about our unit circle. And I know this guy has everything in radians and we want them in degrees. So let's just make that quick note here. So my special known unit circle values in degrees: 30 degrees, 45 degrees, 60 degrees, 90 degrees, 120 degrees, 135, and 150. And we could keep going on around. We don't really need to, but since I'm here, 225, 240, 270, 300, 315, 330, and of course 0 and 360. Okay, so now what we want to do is we want to think about the combination of two of these known angles that could get us to 75 degrees. There might be others, but the one that I'm seeing most easily is that 30 degrees plus 45 degrees equals 75 degrees. So that means that I can rewrite the cosine of 75 degrees as the cosine of 30 degrees, plus 45 degrees. So now, because I want the exact value of this, I'm going to apply an angle sum identity. Now, remember, we can't get the exact value directly of the cosine of 75 degrees because the only exact values we know are the unit circle values. So I had to rewrite 75 in terms of unit circle values, which I did. And so now I'm going to use my angle sum identity. And so what do I know? Well, I know that the cosine of an angle added to another angle is equal to the cosine of the first angle multiplied by the cosine of the second angle minus the sine of the first angle times the sine of the second angle. And I know the cosine of 30 degrees is square root 3 over 2, and the cosine of 45 degrees is square root 2 over 2, and the sine of 30 degrees is 1/2, and the sine of 45 degrees is square root 2 over 2, which then gives me square root 6 over 4 minus square root 2 over 4, and that is the exact value of the cosine of 75 degrees. Okay? Hopefully this helps. Let's take a look at this other example that I wrote down here earlier. And so we're going to do pretty much the same thing, except we're going to use the sine difference angle formula. So we're going to use this guy right here. So the sine of one angle minus another angle the sine of x minus pi over 4 is equal to the sine of the first angle times the cosine of the second angle minus the cosine of the first angle times the sine of the second angle. So cosine of pi over 4 is root 2 over 2. No, it's not. Yes, it is. Times the sine of x minus the sine of pi over 4 is root 2 over 2 times cosine x. And this is what we're looking for here. We're just looking to break that out. And we'll talk a little bit more about this technique in terms of solving an equation in the next video.